Okay, so something different. I'm going to talk about data, modelling as such, or uncertainties. I'm from Rothamsted Research. It's an agricultural research institute, one of 8 research institutes in the UK, BBSRC funded, so biological sciences. And I'm going to talk about 4 farming systems where we've been collecting the data for 15 years now. So we capture all the processes for these 4 farming systems over the last 15 years. Now this data would be really useful for remote sensing as ground reference. So that's the idea of the talk. My background, I'm a spatial statistician, that's why I went on about that question just now. Right, so outline sort of challenges facing agriculture. I'll describe the data sets. They're all open. A little bit on process-based models, which are complementary to those data sets because we can't measure everything. Just a few analytical snippets of what we can do with data sets. And some science ones. I may get onto digital twins, but let's see how it goes. Yeah, just also on the other side there, we've got the bioscience research infrastructures. So at Rothamsted, we've got 3 of them. We've got the farm platform, which has been going since 2010. The insect survey, which has been going since the 60s. And we've got the long-term experiments, which has been going since in the 1800s. It's the longest agriculture experiment in the world. We like doing the same things over and over again. Challenge. So the challenge, agriculture challenges, the context of climate change. So greenhouse gas emissions, especially from livestock farming, grassland farming. The other point here is agriculture both contributes by the greenhouse gas emissions, but it's also affected by climate change, extreme events, extreme rainfall and drought and so forth. The idea is to do some mitigations and interventions, and that's the impact. So I'm going to talk about grassland farming mainly, livestock farming. And so 40% of Great Britain is grassland farming, so it's important in Great Britain. And 25% of the ice-free surface is also grassland. So it's one of the main way we get food. Just 2 concepts here: sustainable versus resilient farming. Just the analytical toolkits that you use. When you're doing sustainable farming, you're sort of balancing these trade-offs. So you want your farm to be productive, but you don't want it to be too pollutant. And there's also a social aspect. So that's sort of trade-off concepts. We're moving more towards resilient farming. Here we're looking at generally time series data, looking for signs of stress, slowing down in the system, changes in variance, covariance, rather than trends. Or changes in the mean, that's not so important. It's changes in variability. Right, to understand sustainable and resilient farming, we need data. Let's move on to the data platform. So here it is. It's basically 3 small farms in the middle of Devon, down the road, just outside Oakhampton, off the edge of Dartmoor. Those 3 farming systems, so it's 3 outdoor farms and 1 indoor farm. 3 outdoor farms are all the same system to start with, all grassland farming, the same pasture. And then periodically we change the farms. In the first instance, so the one in the middle there, we changed 2 of the farms to improved pasture type. One was just high sugar grass, one was high sugar grass plus clover mix. And then, so that was in 2013, so all started in 2010. 2013/15, we changed it to 2 of the farms transitioned to different systems. And then 2019, the red farm went to an arable farm. That's where we are at the moment. We've got 1 arable farm, 2 grassland farms. But we also created an indoor farm when we created the arable farm. So we've got 1 indoor farm, which is the brown one up in the corner there. So each of those 4 farming systems, 3 outdoor, 1 indoor, we just collect as much as data as possible on the inputs, the outputs, productivity, emissions, water, gas emissions. For the outdoor ones, the soils, the crops, biodiversity, and a whole host of data collections. And it's all made open. The idea is we're comparing those 3/4 farming systems with sustainability and their resilience using the data. Whenever we change a farming system, we have a hypothesis, a series of hypotheses, what we expect and what we're going to test for, and they're listed there. You notice the bottom one's crossed out because when we did the second system change, it was during COVID and we couldn't implement it. It was too difficult. So we only changed one farming system in the second time. So if you think we got so we've got data on land use change, we've got data on management, and we've got data on emissions and sort of productivity of the free outdoor farms. Of course, with remote sensing, the indoor farm doesn't really make any sense. Capture it there. So here's our data sets. This is the most interesting slide, I suppose. So we've got more detailed farm management events. We know exactly what's gone on. So when you're doing remote sensing stuff, you know exactly what's happened on the farms. We've got crop performance, quality and quantity. The middle column is all the data that's made open. The final column, some data is open, some's not. But it's not in the same, what we call the data portal. Got livestock performance, live gain and their condition. Got the met data, which is co-located with an official Met Office site. Got soil moisture data. Got water emissions, which is the jewel in the crown. Got water emissions from the fields, the farm. They're hydrologically isolated, so we capture all the water runoff and all the water chemistry. We've got greenhouse gas emissions from eddy covariance, only in 3 fields, 1 field in each farm. It's expensive. We've got some plant surveys that happens every 3 months. We've got some detailed within-field surveys that are quite nice and spatial. And we've got biodiversity stuff. We've got quadrant surveys. And then in the other collections, the ones that are open and closed, we've got bioacoustics, transect traps, genomics. So many of the data here are actually open. You don't get through the thing called the data portal. So there's the website there. In addition, so not only do we release the data, make that open, you can also use the farm platform as a facility. So you can come and conduct your own experiment, collect additional data, and it can complement the data that we routinely collect. So with the ESSA presentation earlier on, there was a slide on agricultural proposals. So you could use the farm platform for a research proposal. You're welcome. Here's the data in a different form. Don't look at the detail in the table. But basically, the ones in yellow, the data goes straight to the cloud. The ones in grey, it's got the potential to go straight to the cloud. The ones in orange is all manual collection. So most are still manual. This does affect a latency of when we collect the data until we make it open. It's all got to go through a quality control process and stuff. But the more manual collections may take longer to be open and released. Even the automated collections, it's still about 3 months from collection till we release it. It's still got to go through a quality control. So all this data is available for research purposes and industry purposes too. It's always nice to see the data in more pictorial form. So you've got topography, soil class and boundaries, so that's fixed data, that stays as is. Farm management and weather data, that contextualizes everything. It's really, really important. Soils data, chemistry, field surveys. You've got some data on livestock movement, where the cattle and the sheep go, moving around the field. Dung and urine patches, important for the greenhouse gas emissions. Disease and pests. And ones on the bottom here, they're quite extensive, especially the emissions. The emissions to water and air. Very extensive, livestock performance, and increasingly we're getting more and more of this biodiversity data. We can't collect everything, can't measure everything. Some things that we can measure are too expensive to measure or collect. So we've also got experience of process-based models to simulate these processes. We can easily measure or collect. So there's And there's an overlap, even though we've got plenty of measurements, got over 100 million measurements already, you can still do more with process-based models, still missing a lot. And the overlap there is actually where you can do the validation of your process-based models. But when you're simulating from your process-based model and you happen to have some measurements, then you can validate your process-based model. So these are mathematical models. All right, so the geographies of the farm platform, you've got up there the system changes. You've got a fourth map there because we're going to do another system change in next year, 2026. We don't know what we're going to do yet. So these are the timelines of the different land uses in essence. You've got here a off-farm platform design experiment to decide what wheat to grow. We do these additional experiments outside the farm platform to inform what we're going to do on the farm platform. Most of our science has been at the farm platform scale, the free outdoor farms, but we can start to outscale and influence what we find on the farm platform nationally, in part because we also monitor the catchment that the farm platform sits in. You've got that little yellow star there, that's where the farm platform is, but we also monitor the catchment. So when we're outscaling from the farm platform, the free farm to the farm platform, we can influence about 5% of the UK, but knowing the land use and the instrumentation in the Earth, as the Upper River Tor Observatory, we can go to about 45%. And this outscaling is both remote sensing, that's national surveys, farmer surveys, agricultural survey, and so forth. So that's all possible. So here's the, this is how you get the data. You just got to register, and you can download the data sets. You can even do it for the data portal. We also have APIs, but they're in the testing phase, so it'd be good to sort of evaluate them if you're keen on this data set. Our APIs are probably about 90% done. They don't capture all the data in the data portal. And we've also got lots of so we call them non-core worked up data sets. Non-core data sets from a sort of campaign experiment, a sort of mini experiment, just maybe one field or one farm. We've also got worked up data sets from the data portal, but they've been aggregated or something, they've been manipulated, they've been infilled or something like that, that they could be useful. Yeah, it's an open facility for campaign-style experiments. With the publications that we've already done, plenty of opportunity to do the same analysis, but with machine learning, deep learning tools. So you can just repeat the same thing. So there's plenty of science publications, different components of the system. Some focus on livestock, some focus on water emissions, some do the gas emissions, some look at sustainability and the trade-off. So there's a whole host there. So let's do some analytical ones. So here's some example of remote sensing. So one's looking at remote sensing combined with field data to predict soil organic carbon. That one has a focus on different covariates, different predictor variables or your features, some that are readily available, some that are not readily available. See how accurate you can get your soil organic carbon predictions with remote sensing, which is Landsat. And then the second one, this one here, this is predicting ploughing events. So changes in carbon dynamics according to events what the farm is doing. Right? Because we got the records, we know exactly what ploughed and what type of plough was used. So that's another modelling exercise. This one used a GAM, a generalized additive model. This one was a hybrid between a process-based model and a machine learning model. I can't remember the machine learning model. You can do sensor design. This is an example of sensor design at different scales. How sensors can be placed according to whether you want to put them in a particular field of your farm, whether you want to cover the whole farm, or actually if you want to share your sensors with your neighbours, that's what this one here does. And here you actually start to put sensors on your neighbour's farm, because at the three farms together, you get good coverage. And this is the soil moisture example, I think. And here's an example of extreme events. coupling a process-based model with a data-driven model.
Out of time.
Right. 3 slides into
30 seconds.
Right. Digital twins, so we've got lots of projects doing digital twins, decision support, yep, that. And then here's a schematic for the digital twin. There's your data. So that's your real farm, that's your virtual farm. Decision support thing. So you're making decisions by the digital twin. So it informs back to the real farm, but also you redesign your monitoring campaign according to what it's saying and its uncertainties. This example is an emulator one. Options for digital twins. Using remote sensing is good for digital twins. Here's the summary. I think that's it.
Thank you. It's fantastic seeing what I think is one of the best examples in the world of a most instrumented, intensely monitored farm system with the data all being open. So if you've got models and you think, where can I test these against? Fantastic example. We've got time for one more question while Milto, if you come up, we'll get some. Choose your question.
The data's all open. Come and use it.
The bits of data that aren't open, why can't they be open?
It's just our time getting them ready.
Okay. So they are open, there's just a latency?
Yeah, we just got to get them prepared. Yeah.
Okay. I think you could be loud and proud that they're going to be open and that it's just not instant.
There's a latency on the core data, a couple of months behind, a year behind, but the campaign data, yeah, more like years.